Some people really do like to listen to themselves talk. I could care less. Okay, now, so it says state the rule of a sine function with a given amplitude, period, phase shift, and vertical shift. So we need to know, so we're looking for f of t equals a sine of b times t minus c plus d. Okay? Where a is our amplitude, b is 2 pi divided by the what? Well, the period is 2 pi divided by b, right? So to get b, I would do 2 pi divided by the period. Yep. All right. C is our phase shift. And D would be the vertical shift. So for number 21 then, we're going to, let's see, they tell us that the amplitude is 3, so A is 3. B is 2 pi divided by the period. If period is pi over 4, so we have 2 pi divided by pi over 4. So that is 2 pi times 4 over pi, which equals 8. Okay. C is the phase shift, and that is pi over 5. So we just plug them in. So we've got f of t equals 3 sine of 8 times t minus pi over 5. And then when they write their answers, though, is the 8 here or not? Or do they actually distribute it, don't they? Okay. Okay, they showed both? Okay. All right, so this, you'd have this answer and 3 sine of parentheses 8t minus 8 pi over 5. Oh, now it's easy, right? No? All right, so we'll do another one. One more. So let's do 25. All right, let me pull this down so we can see it. Okay, so in 25 then, we have A is 0.5. B is equal to 2 pi divided by 2.5, right? Okay. Which that is 5 over 2, correct? Yes? Okay. So I multiply by 2/5, and we get 4 pi over 5. C is 1.5, so I'm going to write that as a fraction, 3/2, since I'm working with fractions. And D is negative 0.6. All right, so let's see, those answers. Of course, I better go back here, hit that button. And so they did use decimals. All right, so we'll convert it back to decimals when we're done. So we have f of t equals 0.5 is a sine of 4/5 is 0.8, right? Okay. So 0.8 pi times t minus 1.5 and then minus 0.6. Oops, 0.6. Okay. So if we expand it, we have f of t equals 0.5 sine of 0.8 pi t minus, okay, what's 0.8 times 1.5? Oh, no, hold on, okay. What's 8 times 1? What's half of 8? 4, and 8 and 4 is 12, okay? So this is going to be, and how many decimal places do I have here? 2, so I have 0.12 pi minus 0.6. Okay? Didn't need my calculator to do that. I understand. Okay? So, either of those two, they probably gave it, did they give us this answer here? Okay, all right. So, there's the answer to that. Okay, so following that up, when they ask us to describe a graph, that means they want us to tell them about all those specific things. So that means I need to talk about vertical shift, vertical stretches and compressions, horizontal shifts, and horizontal stretches and compressions, right? So I need to find out what all those things are so I can write my description. So the first thing I need to do when I have a problem like this is I need to rewrite it in that other form. So g of t equals 3 cosine of 2 times t minus 1/2 plus 4. Because this tells me all of the specific things I need to know. So this tells me that I have an amplitude of 3, okay? And the amplitude of 3, so amplitude equals 3, so that means that I have a vertical stretch by a factor of 3. Okay. The period in this case is equal to what? Okay. All right, John says the period is pi, and why is it pi, John? Okay, the value of b is 2. 2 pi divided by 2 is pi. So if the period is pi, that means it's been horizontally what? So normally the period is 2 pi. If I cut the period in half, does that stretch or compress it? Compresses it. So this is a horizontal compression by 1/2. Okay. And that should make sense because if our value of b is 2, then when we're talking about horizontal stretches and compressions, we're doing reciprocal. Reciprocal of 2 is 1/2. Okay. The phase shift is positive 1/2, which means it's moved to the right 1/2. And then the plus 4 at the end tells me that it is vertically shifted up to 4, I mean. 4. It's d equals 4. Okay. So here is a equals 3. The period is pi. The phase shift is 1/2, and the vertical shift is 4.
So we don't say like, so we don't say like.
Okay, so when we want to identify amplitude, period, vertical shift, and phase shift, you want to make sure that you, first of all, rewrite it so that you can see the values of A, B, C, and D. So A will tell me the amplitude. 2 pi divided by B tells me the period. The vertical shift is D, and then the phase shift is the value of, B over C, or you can just think of it as C. So the phase shift then, since it has T plus 12, it's minus 12. But I want to look at graphing this for a moment and how you could graph this actually without your calculator. Okay? And this one will be a little bit harder than the example they gave in the book, but let's see if we can do this. Okay, so first of all, when we graph this, we're going to look at the graph of cosine. All right? So, or sine. So let's think about the graph of sine for a moment. And I'm actually going to graph sine, but we're going to think about the main parts of it for a second. Okay? So we're not going to graph anything on the horizontal axis. We're just going to actually, you'll notice that even though I have a y-axis here, I'm not going to use it. Okay? All right, there's no 0 there, but that's going to be where I start. So a reminder that sine starts at the origin, right? Okay. And in this case, it says the amplitude is 2, so it's going to go up 2 and down 2, isn't it? All right, so just okay. So if it goes up 2 and down 2, it's going to go up 2 and down 2 from the vertical shift, which is 1. So in this case, we're going to go up to 3, right? Because the vertical shift is 1, so we've moved the whole graph up 1, okay, from 0 to 1. Okay? And then we're going to stretch it out by a factor of 2. So that means we're going to go up to 3 and down to -1. Okay? So think about the sine graph. Let me just draw the graph of sine in here just for a second to help us out. All right, so let's go by 1. So here's right? So there's kind of our sine graph. Right? So the vertical shift of 1 means that I'm going to take the center of this graph and move it up to 1, and then I'm going to stretch it out by 2's, right? Okay. So we're going to go up to, this would be at 3. So here's 3. And at 0 here, it's going to move up to 1. And -1, it will be shifted up 1. Oh, we're going to multiply it by 2, multiply it by 2, which would put us at -3, and then up 1, -2. Actually, it should be here. Okay, -1, because there's a difference of 2 there. Okay. All right, and then back to 0. All right, now, so the graph is going to look kind of like this. It's going to look like this. So we have 2 different things we need to think about then here. So it's going to come down here to -1, to 0, 3, back to 0. Okay. Now, I have a phase shift of -12, which means what? This middle point here, basically, or everything has been moved to the left 12, correct? Okay. So let's keep that in mind for a second. The other thing is the period is 6 pi. So this x value here, all right, would be 6 pi before we do the vertical shift, wouldn't it? Or the horizontal shift, right? Because I stretched it out, okay? This spot here would be 3 pi, okay? And here we're at 0. So if I had a phase shift of negative 12, that means then that this would really be at negative 12, wouldn't it? Right? Because I moved it to the left 12, which means then this spot here is going to be negative 12 plus 3 pi, because I moved it 3 pi to the right. This would be negative 12 plus 6 pi. Now let me ask you this. Where's 0 at? So the big question is, where is 0? So I need to know where my vertical axis is. Okay. What's 3 pi equal to? What's the numerical value for 3 pi? Anybody know? Take your calculator and do it. I mean, you should kind of have an idea in your head, right? Pi is 3.14, right? So 3 pi would be about 9.5. Correct? Okay. So then, this isn't quite to 0 at this spot here then, is it? Okay. What's 6 pi? It's what? Almost 19. Okay. So 19 minus 12, this then, is actually approximately 7, isn't it? This is about negative 2 or negative 3. Okay. There's 7. So what about this spot here? What would this spot here be? What's this x value? Well, let's see. What's halfway between 3 and 6? 4.5, right? Okay, what's 4.5 times pi? 14.14. Okay, so negative 12 plus 14 is about 2 then, isn't it? Okay. So this is approximately 2 here. All right, so then my y-axis is going to be basically almost halfway between these two, right? A little bit closer to the 2. So here's the y-axis. There's 0. Now, any of that make sense? Honestly, no. Okay. But think about what we did, okay? We took 0, the point that normally would be 0, we moved it to the left 12, okay, because of the phase shift was negative 12, okay? The period is 6 pi, okay? So from 0 to 6 pi, I have 1 cycle. So if I took and moved that graph then, so if I took every increment here where my x values are and I subtract 12 from them because I'm moving them all to the left 12, so all I have to do is take those numbers and subtract 12, okay? And that gives me the value of those and where they're at later. Better hit that first. I'll write on it, okay? All right. Just, you can think about that for a while. Chew on it, the example. All right. So here's the one in the book. All right, so let's talk about this one first of all. We want to find a sine and cosine function whose graph looks like that. So I could type it in my calculator and get that exact thing. Okay? So what we need to do is we need to identify A, B, C, and D. Okay? So that we can just plug them into our rule. Okay? So when we're all done, we have a function that looks like this. So the thing is, though, is with sine and cosine, we're going to have different values of what? Which one of those four is going to be different for sine and cosine? C is, because their max and min values are at different spots. Okay? Because sine goes through the origin, cosine has a max at the on the y-axis. Okay? All right, so first of all, the value of A, that's how far it's stretched out, okay, from the center. So in this case, the value of A would be what? 2, right? So from the center here, okay, from the center, the graph goes up 2 and goes down 2. Okay? So the value of A is 2. Right? The value of B tells us the value of B is 2 pi divided by the period, right? B equals 2 pi divided by the period. Okay? All right, well, how long is the period in this case? Or how long does it take to repeat itself? All right? Or let's think of it this way. Okay? My whole window is from negative 2 pi to 2 pi, right? My whole window is from negative 2 pi to 2 pi. How many times does it repeat itself in that? Twice, right? Okay. So the period here would be 2 pi. Okay. Because it starts here. It starts here, goes up, comes down, and back to there. Okay? That would be one cycle, right? Okay. So that's 2 pi. So 2 pi over 2 pi would be 1. All right, so that's easy. B is 1. Okay. Now, the phase shift. The value of C for sine and cosine is going to be different. For sine, I want the graph to look like this. Okay. For cosine, I want the graph to look like this. Okay, right? So for sine, I need to move it back to the origin. For cosine, I need to move the max to the y-axis. So here they're really nice. They give us these numbers. They tell us that this is pi over 4, this is 3 pi over 4. Okay. So if I take, and this graph has been shifted pi over 4 units to the right, okay? Which means then that the value of C for sine would be positive pi over 4. For cosine, it would be positive 3 pi over 4. Okay? Because it's been shifted pi over 4 from what sine would normally be. It's been shifted 3 pi over 4 from what cosine would be normally. Okay? And the value of D is the vertical shift. Has this been shifted up or down at all? No. Okay? So the value of D is 0. So my equations then are going to be f of t equals 2 sine of t minus pi over 4. Okay. B is 1, D is 0, so we don't need them. And f of t equals 2 cosine of t minus 3 pi over 4. Now, there is actually an infinite number of correct answers here. Because, yes, I used pi over 4 and 3 pi over 4. I could have used this value here for sine and made it a shift going that way. Or I could have gone to here for sine or for here for sine. If I went to this one, then I would actually have, it would be reflected then, wouldn't it? Because it's going down first instead of going up. So that, if that case was, then I'd have negative 2 sine or whatever. So there's a lot of variations for what it could be. But we're looking for where has it been shifted over? Find the amplitude, find the period, shifted up and down for D, our vertical shift. And then for the value of C, we're looking for where is it gone horizontally? What was their horizontal shift? All right, so let's look at another one. Here's the one that was on your paper, right? So, in this problem, A is what? How much has it been stretched out? 3. So my amplitude is 3. Okay. They're really nice here again, and the period is, okay, the period is 2 pi, so B is 1, okay? Remember, B is the number of cycles in 2 pi, so if it happens once, then it's 1, okay? How about D? Has it been shifted up or down any? No. Okay, so that's 0.
Do we always first put sine and cosine?
You need a value for sine and a value for cosine, because they want us to do a sine function and a cosine function. All right? And for sine, like I said, for sine, we're looking to see when it goes through we want it to go up. For cosine, we're looking for a max. Okay? So here we have, like I said, they're really generous here, that they tell us that here's a max at negative pi over 6. Here it goes up. Here it goes up at negative 2 pi over 3. So they give us those numbers there for us. So for sine, it's going to be negative 2 pi over 3. And for cosine, it'll be negative pi over 6. So we have f of t equals 3 sine of t plus 2 pi over 3. And 3 cosine of t plus pi over 6. Okay, so I'm just looking for when it goes up. Okay. They want to know whether these are possible identities. Remember, that means if they're identities, they are equal to each other. Okay? And so all we're going to do here, we did a little bit of proving of that, right, in chapter 6. We're going to do more proving of it in chapter 8. Okay? But right now, all we're going to do is use our technology. Okay? So if you take out your calculator, and I'm going to make sure I'm in radians, because we're going to use radians instead of degrees for this. It's much easier. Okay. And we want to know whether these are identities. Now, this wasn't here's the one you had, right? Number 7. Okay, so we'll do this one. Okay. All right, so I'm going to type in sine of pi divided by 2 minus x. And then I'm going to type in cosine of x. Right? So put one side in y1, the other side in y2. And where's the best place to determine whether these are the same or not? The table. Okay, the graph is nice, but the table is better, because if I look at the numbers, if they're the same, then it's an identity. If they're not, then obviously it's not. And so the tables are the same. So yes, it's an identity. Letter B. All right, so you guys go ahead and do letter B then. Okay. All right, so number 8, we're doing the same thing, except our functions we're using are a little bit more difficult. All right. Now here's where the fraction key on your calculator will come in handy if you have it available. If you don't, then you just have to work with it. So I go to my y equals here, and when I put it in my y equals, right, cotangent is the same as what? 1 over tangent, and cosecant is 1 over sine, okay? So we have 1 divided by tangent of x divided by 1 divided by sine of x and then 1 divided by cosine of x. Okay. So you have to be very careful when you type them in. All right. And let's look at it graphically. Graphically, here is our first one. That looks a lot like sine, or cosine. Okay. And that looks a lot like secant, and those are definitely not the same, are they? All right. Now, let me explain to you another way you could do this. All right. So if I go to my table, definitely not the same. Okay. So those are not the same. Now, here's something else you could do. All right. You could, if that's hard for you to type in, all right, you have a hard time with that. What I could do is I could put 1 divided by tangent in y1. 1 divided by sine in y2. Do what? Cotangent and cosecant? Because we don't have those functions in our calculator. Right? We have sine, cosine, and tangent. We don't have. Nope, they can't do anything. There you go. Yep. Okay. So notice what I did. I put the numerator in y1, right? The denominator in y2. So then I could go alpha calc and say y1 divided by y2. Okay. Okay. So you could put the numerator y1, denominator y2, and then just say y1 divided by y2, which would be the same thing. Okay. Just make sure you turn, if you do that, you just got to make sure you turn these off so that they don't graph. Okay? All right, just a second. Okay, so that one definitely doesn't work.